In this question, we are trying to calculate the final temperature of the water in the can. This means that we're eventually going to be using the QMAT formula to find out what is the final temperature. Given that they have already provided us with the mass of ethanol, what we're going to be doing first is we're going to calculate the number of moles of ethanol that has reacted. So we could just go mass divided by molar mass. That gives us the number of moles. From this point onwards, what we can do now is we can actually calculate how much energy is released from this amount of moles. So given that delta H is equal to Q over N, we can rearrange this formula to calculate the energy released by going delta H multiplied by N, and the delta H value can be provided in the data booklet. So I'm going to go 0.04543 multiplied by 1,370. This will give us the total amount of energy released by ethanol. However, since the question has told us that there is only a 60% efficiency, only 60% of the total energy is actually going to be absorbed by water. So I then multiply that by 60 over 100. And so therefore the total amount of energy that's released and therefore absorbed by water is going to be 37.35 kilojoules. Okay, so this over here is the the energy absorbed by water. Okay, and that's what I've shown down below. Just remember that when you are using the QMAT formula, that the energy of water needs to be in joules. So that's why I've done that over here. And now I'm going to plug this value in along with all the other values and rearrange for T final. So my next step is I'm just going to divide this number here by these two values, and then I'm going to add 25.3 on both sides. And when I correct this to two significant figures as given by a percentage, your final answer should be 70 degrees Celsius.